Hello and welcome back to another example of kinetics using work energy method. Here we have a spherical ball that is released from rest on an incline as shown here. We're interested in determining velocity of the ball when it reaches the bottom of the ramp. Observe that as it rolls down without slippage, its center has a velocity, let's call this v. It is also rolling in this direction, so it has some angular velocity omega. Recall from kinematics that if there is no slippage at the contact point, then we can relate linear velocity to angular velocity, so v equals to r omega. This is one equation that I want to consider from kinematics. As far as kinetics of it is concerned, I want to write the work energy relationship. Work equals to change in kinetic energy plus change in potential energy. Observe that there is no external force acting on this. There is no applied force, so net work is zero equals to here we have a rigid body plane motion, which is combination of both translation and rotation. Therefore there are two components of kinetic energy, one due to rotational motion, 1/2 I omega squared. This is omega final minus, or I should say plus 1/2 mv squared, since I have a translation as well as rotation. So kinetic energy has these two components, and observe that potential energy due to weight change in potential energy is actually decrease in potential energy, so I write minus mg delta h. Delta h here is 1 or 0.1 meters. So if I continue with numerical calculation, observe that here this equation seems to have two unknowns, one linear velocity and one angular velocity, but I can plug in for omega using this equation. I can write omega equals to v over r. So if I plug for omega, I basically have one unknown to solve for. Then continuing with numerical equations, I have 1/2 I. Recall that I for a spherical ball is 2/5 of mr squared, so I have 2/5 of mass, which is 5, radius, which is 0.05 squared, 1/2 I times omega squared, but omega is v over r, so I have v squared over r squared. I can plug in for r, which is 0.05 squared, plus 1/2 mass of 5 kilograms times v squared minus mg delta h is 0.1 meters. Observe that this equation has one unknown, which is v, so I can easily solve for it. Observe that these factors cancel out, so I basically have v squared for the first term plus 2.5 v squared, which gives me 3.5 v squared equals to 5 times 9.81 times 0.1, which turns out to be 4.905. We can solve for v squared and then take square root of both sides to end up with a velocity of 1.18 meters per second. So when it reaches at the bottom of the ramp it has a velocity of 1.85. Thanks for watching, and I hope to see you again.